So we had just figured out what the Maclaurin series for this function is going to look like. And the cool thing about it is that we can actually write this series no matter what number k actually is. So you might call this a family of functions, which are all parameterized by k. And they all behave similarly. So we were already saying that if k was a whole number, then we're just going to get a polynomial. But, we kind of knew that already. 1 plus x raised to in a whole number power, that's absolutely a polynomial. Now, if we want to have a k that's not a whole number, we're going to use the ratio test. Take the ratio of successive terms in the sequence, and there's going to be a lot of cancellation. So in my numerator, I will have k minus n. But I'll have the absolute value of k minus n, because that may or may not be positive. In my denominator, I will have n plus 1. And then all of this will be multiplied by x, right? Those are the only things left standing after I do my cancellation. And to make it more obvious what's going on in this limit, we can rewrite it in this form. Divide everything through by n. And as n goes to infinity, my numerator is going to go to 1, right? 1 minus 0. And my denominator is also going to go to 1. So what's left over? I've got the absolute value of x. The ratio test tells me that this series converges as long as the absolute value of x is strictly less than 1. And it will diverge as long as the absolute value of x is greater than 1. So here is another series, and it will converge to a function so long as we are between -1 and +1 on the x-axis. Now, there is a notation for this special kind of coefficient. If k is any real number, then we start at k, multiply by k minus 1, k minus 2, and so on until we stop at k minus n plus 1, all of that divided by n factorial. So the name for this is the binomial coefficient. Depending on where you go in your major, these may or may not play an important role in what you do. They certainly show up in my work all the time. So, is this function 1 plus x to the power k equal to the power series that we just calculated? Remember, this is not automatic. This is something that we need to check and verify. The answer is yes. For the function 1 plus x raised to the k power, and again, k can be any real number, so long as the absolute value of x is less than 1, then 1 plus x to the power k will be equal to this Taylor series. Start at 1, add k times x, then add k times k minus 1 divided by 2 factorial times x squared, then add k times k minus 1 times k minus 2 divided by 3 factorial times x cubed. If I stop anywhere, I'll just get a polynomial. That polynomial will approximate the function that I care about. And in the limit, this infinite series will be exactly equal to 1 plus x to the power k. And again, this will work for k, whether that's a whole number or real number.